The first question, fx equal to x cube minus 6x square plus 11x minus 6 on the interval 1 comma 3. Verify Rolle's theorem. Verify Rolle's theorem. Wait a minute. Rolle's theorem. Now, answer. First point. Fx is a polynomial. So continuous. I'm writing CTS. You write full on 1 comma 3. Second, fx polynomial is differentiable, derivable everywhere. So derivable on open interval 1 comma 3. Now the third point is, let us find f of 1. F of 1 is 1 cube minus 6 into 1 square plus 11 into 1 minus 6. This is nothing but 1 minus 6 plus 11 minus 6, that is 12 minus 12, that is 0. Now f of 3. 3 is 3 cube minus 3 into 3 square plus 11 into 3 minus 6. So this is 27. 9 6 are 54 plus 33 minus 6. So this comes out to be 60, and minus 60 again 0. So f of 1 is equal to f of 3 is equal to 0. Therefore, there exists. Now all the three conditions have been satisfied. Now, so therefore, there exists a point C. There exists a C belonging to open interval 1 comma 3 such that f dash C is 0. Now we know the polynomial is what was the polynomial? Fx was equal to your x cube minus 6x square plus 11x minus 6. Take the derivative. F dash x. F dash x is 3x square minus 12x plus 11. Now if this f dash c is 0. F dash c is 0. That means you put c here. Put c here. यहाँ पे c put करो और उसको 0 कर दो. That is f dash c is 0. Therefore 3c square minus 12c plus 11 equal to 0. So this is a quadratic equation. C is equal to plus 12 plus minus under root 144 minus 33 into 4ac. The 33 into 4, that is 132 upon 6. That is 12 plus minus 2 and 1. 12 under root upon 6. So this comes out to be 12 plus minus 2 under root 3 by 6. So this comes out to be 2 plus minus under root 3 by 3. Under root 3 by 3. So this 3 by under root 3. So this is so therefore C is equal to 2 plus minus 1 by under root 3, and this lies between 1 and 3. Therefore, Rolle's theorem is verified. Rolle's theorem is verified. Let's take another problem. Now, let us take this. Yes, a good problem. Question. fx equal to sine x upon x for on 0 comma pi on 0 comma pi. Verify Rolle's theorem. Verify Rolle's theorem. Rolle's theorem. Theorem. Now, the first point is now as sine x and x, sine x and x, I think it is sine x e to the power of x. I made a mistake in this question. Sine x and e to the power of x. Sine x and e to the power of x are continuous. So, you know, f and g are continuous, and f by g is always continuous. F by this theorem, f and g is continuous, then f by g is continuous. So this whole thing is continuous. So f continuous. So fx. So fx, that is this whole thing. This whole thing is continuous on 0 to pi. Let's rub this. Now, second, both these functions are differentiable. Both these functions are differentiable. Sin x uh, so f dash x, if you write f dash x, see fx is, both these functions are differentiable. See fx is what? Fx is sin x upon x. Now you take f dash x. F dash x is sorry, e to the power of x. I don't know why I'm writing this. So e to the power of x cos x minus sin x e to the power of x upon e to the power of x whole square. So cancel e to the power of x from the numerator and the denominator. Cancel one each. That is cancel this and the power. So you will get fx is equal to cos x minus sin x upon e to the power of x, and is derivable. So this exists, f dash x. This is f dash x exists in open interval 0 to pi. Third, f of 0, that is sine 0 upon e to the power of 0 is 0 upon 1, and this is 0. F of pi is sine pi e to the power of pi is 0 by e to the power of pi is 0. So f0 is equal to f of pi, the third part of Rolle's. So f0 is equal to f of pi. So the third part of Rolle's theorem has been verified. There exists a c belonging to 0 comma pi such that f dash c is 0. Already you have found out what is f dash x. Just put f dash c. So cos c minus sin c upon e to the power of c is equal to 0, implies cos c minus sin c, cross multiply this, you will get 0. Take sin c there. So cos c minus is equal to sin c, divide by cos. So you will get 1 equal to tan c. That means c is equal to pi by 4, because tan 45 degree. This is nothing but 45 degree. Let me rub it. This is the pi by 4. So tan 45 is 1. This is tan. This is tan 45, tan c. So c is pi by 4. Being pi by 4, c lies between 0 to pi. So Rolle's theorem is verified. So verified. I'm writing in short. So a Rolle's theorem RT is verified. You will write the full. Now let's take another problem. Let's take another problem. Question. Fx is equal to mod x for minus 1 to 1. Now see, mod function is continuous, I have told you. Now see, fx basically is nothing but mod x, and that is nothing but x for x greater than equal to 0 and minus x for x less than 0. So these two are polynomial. This is a polynomial. This is a polynomial. So it is continuous. Mod function is continuous. So number one, fx is continuous on -1 and 1. Let's check differentiability at 0. This is the point. जब भी मॉड देखोगे ना, उसको जब तोड़ोगे, उसके जहाँ पे ये चेंज आ रहा है, जहाँ पे ये पॉइंट्स आते हैं, जहाँ पे चेंज हो रहा है, वहाँ पे चेक करना पड़ता है डिफरेंशियबिलिटी. Wherever you see a mod function, wherever this change comes, wherever the function breaks, at which point, at the points, you need to check differentiability there. So take RHD. F dash 0 plus is limit x tending to 0 plus f of x minus f of 0 upon x minus 0. This is nothing but limit x tending to 0 plus x, and f of 0 is at 0 it is 0. This is x, no? At 0 it is 0. F of 0 is 0 because of this part. Because of this part. Because of this part. F of 0 is 0. So x, this becomes x by x number of times I have done. This comes out to be 1. Now R LHD f dash 0 minus limit x tending to 0 minus fx minus f of 0 upon x minus 0 is equal to limit x tending to 0 minus. Now take this function. Wait, let me rub it all. Let me rub this. Take this function. Take this function. This one. Let me rub this point also here. Yes. Take this function because it's less than 0. So this is minus x minus 0 upon x minus x. So this is nothing but minus 1. The right hand derivative is not equal to the left hand derivative. So it is not derivable. It is not. So f dash 0 plus is not equal to f dash 0 minus. So not derivable. So fx, fx is not derivable, derivable on 1 and this. So Rolle's theorem fails. I'm writing short. Rolle's theorem fails.